All right. So, hello everyone. Can you hear me? Can you send a small text so that I can tell that you can hear me here? So we're 10 so far. All right. Great. Hello. Ah, cool. Yeah, that's perfect. So far we are 10. We can wait a little bit for others to join. So yeah, meanwhile, hello guys. I'm so happy that you joined this workshop. It's an introduction to JAX. I don't know if you're familiar with the thing or not. It's pretty new. It's kind of trendy nowadays. So, have you heard about JAX before? Not really. First time. Yeah, that's fine. So yeah, that's the goal of the workshop. I'm going to introduce you to JAX. It's pretty cool. It's so easy and performant. You're gonna love it. So we're 11. Let's wait 3 more minutes because we're expecting more people to join here, and then we can start right away. So yeah, meanwhile, if you have anything to say, feel free to just type your message in here, and I'm going to answer it. All right? So yeah, meanwhile, in this workshop, we are going to be. I will try to be as interactive as possible with you. So I'm expecting you to do some exercises with me. We are going to code together using JAX. All right. So it's much better if you go to your computers, maybe go to Google Colab, or you can just work locally. So yeah, if you are just following me with your cell phone, maybe it's better if you go to your computer now. And yeah, turn it on because we are going to need this later on. All right? All right, I think we should start. So one more time, please let me know if you can hear me, if you can see the video, and if you can see my screen, because I just shared the screen with you. So please let me know if everything is okay. It's all right. Cool. I'll find all good. All right. Cool. So, all right. Again, thank you so much, guys, for joining us in this workshop. It's called Introduction to JAX, and it's brought to you by Code Labs Academy. So yeah, let's just start right away. So first, I'm gonna present myself. So my name is Nazib Ndib. I'm data science content creator at Code Labs Academy, and I'm also a teacher assistant. So I'm one of the teachers who take care of the data science bootcamp. I'm a computer science student, specializing in data science. So I do data science, and yeah, pretty much that's all you need to know. And yeah, I'm an NVIDIA deep learning instructor, so I'm certified deep learning instructor by NVIDIA. And yeah, pretty much that's it. So hello guys, nice to meet you all. So yeah, just before starting with the workshop and stuff, so maybe I should tell you more about who we are exactly. All right. So Code Labs Academy, we are a team of 22 spread across 8 different countries. So we are a team of 22 people, and our home base is Berlin in Germany. All right. So we are a NetTech startup that offers technology boot camps so that we can introduce non-technical people or students into the tech industry. So we offer boot camps in data science, boot camps in cybersecurity, in web development, etc. And we can also offer other educational and career advising services. So all the people that join Code Labs Academy, we are going to take care of their uh, career services. So we can schedule some one-to-one meetings to talk about the careers. We can have some internal workshops in order to talk about the best decision to make in order to get like your dream job or whatever. We also prepare some mock interviews. So in case you don't know what's a mock interview, so we bring a teacher from Good Labs Academy, we bring a student, we put them together in a meet, and the teacher is going to simulate an interview. And yeah, at the beginning, it's going to be hard for the student to follow up, but then he will get familiar with that. All right. So it's either a technical interview, like a coding or programming interview, or it can just be theoretical, like in data science. So the teacher is going to ask some machine learning questions, and the student is going to answer them. So it's kind of training, and it's done in order to prepare the students for the upcoming interviews and the professional life. So yeah, again, we offer financial plans to fit your budget. So the budget shouldn't raise any problem. All right. We have many offers. So it can be either in person or a remote boot camp. All right. So you either come to the spot, or we can do it remotely. And we have two plans. So we have the part-time plan and the full-time plan. All right. So if you want an intensive boot camp, you should go with the full-time plan. And if you want it to be lightweight and spread out over a larger span of time, you should go with the part-time plan. All right. So it's up to you, actually. You can choose any plan, like in person or remote, or part-time or full-time, to fit your schedule. Okay. So for the enrollment, many people ask this. So basically, you don't need any prerequisites. All right. But in the beginning, like in the very beginning of the bootcamp, we are going to ask you to do some pre-work in order to make sure that everyone is in the same base level. All right. So this pre-work is basically free. We are just going to give you some resources, some maybe exercises, in order to make sure that you are in the right level. But that's not something that you should be worried about, because it's pretty easy. So yeah, in Codelabs Academy, what's so special is that we offer a lot of discounts. Okay, so we have many options. And by the way, the fact that you joined our workshop today is going to give you a 10% discount in the next bootcamp. All right, so that's one thing. And we can also have many other discounts. So for example, if you join by group, so you ask a friend to join Codelabs Academy with you, we are going to give you a 15% discount for both of you. All right, so this is the group discount. We can have an upfront payment. If, for example, your previous alumni, so for example, you already took a bootcamp in Codelabs Academy and you want to take another one, we are going to absolutely give you a 30% discount. We have the early bird discount, the super early bird discount, the women in tech discount. So yeah, basically we have many offers for you. So that's the budget, like the financial stuff, shouldn't be any problem. Yeah, about the career services, I feel like I didn't really explain it well earlier. So yeah, we are going to take care of your resume and cover letter, so we can organize some review sessions with our professionals in order to make it perfect, to make it as clear as possible. We can have some portfolio reviews from our teachers, like cybersecurity teachers, data science teachers, etc. We have a really large network with our alumni, so you can chat with them, you can contact them. Maybe they are going to offer you some job or internship offers. All right. As I said, we are going to organize weekly or bi-weekly mock interviews with our students in order to make them prepared for any eventual interviews. We have company career fairs, so we bring companies, and yeah, so we make them closer to you. And yeah, we have monthly career development workshops. So these are some sort of specialized internal workshops in order to prepare you for your soft skills, etc. And of course, you can organize any one-to-one career session with any teacher. So yeah, feel free. You are going to be so free with your teacher, so you can ask them for a one-to-one meeting, and then you can discuss whatever you want. And yeah, so our upcoming boot camps are going to be basically in January. So we will have the next data science bootcamp that will start in January. So we have a remote part-time bootcamp that is going to start on 11th of January, and we have a hybrid, so it's a remote and on-spot bootcamp in Berlin, and it's going to be a full-time. And of course, as you can see here, we will have the UX UI bootcamp that is going to start also, the web development one, the cybersecurity, etc. Yeah, so like today we are having this introduction to JAX workshop. We also have many other workshops. So for example, in the past week, we had an introduction to cybersecurity. We had a workshop about starting your tech career in 2023, etc. And today we are going to have two more workshops. So it's right after this one, actually. So it's an introduction to the web design and development. and we have an introduction to programming with Python. Okay, so make sure to go to our website. So it's codelabsacademy.com. You can find the workshop section in there so that you can like find the whole schedule of the workshops. It's pretty interesting and it's for free, guys. So yeah, make use of it. So, all right. That was it for the introduction of Codelabs Academy. If you have any questions, try to leave it in the chat. I'm going to answer all of them by the end of the workshops. So make sure that if you have any questions, regarding the JAX workshop, make sure to just leave it here in the chat, and I will try to answer them eventually, okay? So we're fine. Are you ready? Please leave something in the chat so that we can start with the workshop. All right, Mary, Selena, Kieran, Andre. Good, perfect. All right. So what is JAX? First of all, let me just ask you a question. Have you heard about JAX? So yeah, excuse me, the class today is not going to be for free. Of course it's for free, it's just a workshop. All right, guys? So yeah, it's for everyone. So that only by name. So is JAX like how you use TensorFlow JS in the browser? So I'm not really familiar with TensorFlow JS. I've never used it before, but I guess it's not. All right? Yeah, that was plain. I'm sorry. So, all right, yeah, that's fine. So JAX is kind of a framework. It's a Python package. All right? So it's Python package that is going to accelerate the work. So it is actually developed by Google. So it's called Google JAX, by the way, and it's a high performance Python package. So I'm going to get the laser point in here. All right. So the main goal of JAX is to accelerate machine learning research. All right. So when we do machine learning, we train many models. We deal with impressive amounts of data. So we need to optimize our functions. We need to optimize our scripts, all right? So JAX is basically built for that. So JAX is going to optimize your code, all right? So if you write your code with JAX, you would be able to run it, like to run some compiled version of it. You would be able to run it on GPUs, CPUs without any like heavy modifications on the code, all right? So again, it's built to accelerate machine learning research, and it's pretty familiar to NumPy. So I think you're more familiar with NumPy than JAX. Have you worked with NumPy before? All right, yep, yes. All right, good. All right, Selena, that's fine. So yeah, for people who are a little bit into machine learning and data science, you should be familiar with NumPy. So NumPy stands for numerical Python. So it's a library that contains many functionalities that are pretty optimized in order to do some Python calculations, like matrices and vectors and stuff. So I just don't like it's more affordable TensorFlow. Yeah, exactly. So actually, a lot of TensorFlow can be run over JAX. All right. But on the other hand, PyTorch is not really made for that. Okay. So yeah, that's a really good point of view. Since JAX is developed by Google, it's more useful for TensorFlow than for PyTorch. But who knows? Maybe eventually PyTorch is going to be customized in order to run over JAX too. All right. So yeah, and by the way, DeepMind is building like many frameworks over JAX. Like they already built a framework to do a graph deep learning. So I think they called it Giraffe, something like that. And they already built a framework over JAX in order to do some deep learning stuff. So it's not really stable so far, but yeah, like a lot of companies, a lot of open source startups are building frameworks over JAX because it's super easy to use and it's super fast. So with JAX, we can build differentiable Python functions. So I think that that in machine learning, we use a lot of derivatives. We use a lot of gradients. So for example, to train neural network, you need to do what we call backpropagation, which is basically just calculating the gradients of a function. So the gradients are the derivatives that we learned in high school, okay? So it's just some simple math calculus. So with JAX, you can just create a function, like a Python function with, for example, def f x return 2x squared, all right? It's just so Pythonic. And then with just the use of a decorator, just put jax.grad. It's going to give you the gradient of that function. So it's going to return another function that is going to give you the derivative of that function. It's super cool. We are going to see it in code later on. So basically in JAX, we are going to have automatic differentiation, and it's pretty useful. We are going to have the just-in-time compilation. So here, instead of just writing a function and running it, what we are going to do is that we are going to compile it first, so that it's going to be much more optimized, and it's going to be compiled. And then we are going to use the compiled version of the function. All right. So yeah, this one is pretty easy, useful, and this is what actually offers all the speed to JAX. All right. We also have the vectorization and parallelization. So the vectorization is used when we deal with vectors, with matrices. So basically, we parallelize, for example, the addition of matrices, the addition of vectors. So wherever we have like a vector and we try to map a function on it, we are going to use this vectorization method because it's going to give a much more quick code, fast code, all right? So you may be asking, why should we use JAX? Because, we have a lot of optimization frameworks like CUDA, we have OpenMP on C and C++, etc. We already have NumPy, we have PyTorch, we have TensorFlow. So we already have a lot of frameworks. So you may be asking, why should we use JAX? The very first reason is that we won't need to learn any new API. All right. So for the people who already dive in machine learning and deep learning, we use a lot of NumPy. And if you try to use TensorFlow or PyTorch, you are going to find it easy because it's pretty familiar, all right? So we have arrays, we have tensors in there, we can calculate the mean and the variance in the same way, basically. So the API of NumPy, PyTorch, and TensorFlow is basically so similar in terms of syntax. And JAX is going to follow the same pattern. So basically, if you take a NumPy program and you try to transform it into a JAX program, what you have to do is that you only need to replace the np dot with the jax.numpy dot. All right? So we are going to see some comparisons between NumPy and JAX code, and you are going to notice that it is so familiar. So this is the very first reason. We won't need to learn any new API. And one of the things that I really love about JAX is that it's going to automatically run on GPUs and TPUs, all right? So if you take a code that runs on CPU, the same code is going to run on GPUs and TPUs. So you don't need to modify any code. You don't need to add anything. But on the other hand, for example, NumPy does not run on GPU or on a GPU or TPU, all right? It only runs on CPUs. And for example, if you take PyTorch, a PyTorch code, in order to make it run on a GPU, you need to do CUDA, and you need to take like an array or the model into the GPU, so you need to add the device, etc. If you're working with TensorFlow, for example, if you want to work with TensorFlow over a TPU, you need to modify the strategy, etc. So it's going to be a little bit more complicated. But here in JAX, exactly the same code is going to run on the GPU, and the same one is going to run on TPU. So it's really easy to use. So yeah, first of all, how to install JAX. So it's going to be installed pretty similar to any Python library. So all you need to do is that you go to your CMD or your terminal, and you just type pip install JAX. All right. Or you can also do pip install upgrade JAX CUDA. So this is in the case where you have like an old version of JAX and you want to upgrade it. All right. So yeah, I don't know if I should wait for you to install JAX on your computers or not. So please, I'm going to give you a minute. Just go to your computer, go to the CMD or the terminal, type pip install JAX, and yeah, it's going to take a few seconds to install, I guess. No, so yeah, CUDA only runs on NVIDIA hardware. All right, this is like a downtrack of CUDA because it only runs on NVIDIA. So for example, me, I have an AMD Radeon GPU, and I can't run CUDA stuff. But that wouldn't raise a problem because I'm going to work on Google Colab, so we can do all the work in Google Colab. All right. I don't think it does. All right. I believe that JAX only supports CUDA stuff. All right. Only supports NVIDIA hardware. Yeah. But that's something that they are already working on. All right. They need to adapt JAX and XLA over other hardware like AMD hardware, etc. Okay. All right. Installed. Thank you, Selena. Thank you, Arnold. So yeah, please guys, go to your terminal or your CMD and just install JAX. Otherwise, if you don't want to install it, that's fine because we are going to work on Google Colab, okay? So in Google Colab, it's pre-installed in there, so we are just going to import it and work with it. All right, have anyone installed it other than Selena? Yeah, so I'm going to give you, yeah, it's just import JAX. Yeah, definitely. So I'm going to show you how to run things in Colab when we start coding. All right. Yeah, it's kind of ironic because it's so similar to NumPy. So basically, you take the NumPy code, and instead of doing np dot, the name of the method, we are going to do JNP, because JNP stands for JAX NumPy. All right, and it's going to work basically, unless you have like some really super complex code, in which case you may face some complications, some problems. So all right. Let's start with some code comparison between JAX and NumPy. Okay, so here I made two sections. So this is the NumPy section and this is the JAX section. So here we are going to do a dot product. All right. So for the NumPy code, like the one that we are pretty familiar with, so it's import NumPy as np. X will take np.arrange, start 0 and stop 1000. So basically here we are creating a vector from 0 to 1000. So it's a vector that's going to contain 1000 elements. And what we're trying to do is that we're trying to do the dot product between this vector and its transpose. All right. So basically, we are going to do the sum of the squared elements in here. And here, if you take a look at the JAX code, it's so similar. So here we do import jax.numpy as JNP because JAX has its own version of NumPy. And then we are going to use JNP instead of NP, okay? So X will take JNP.aRange, and then we will use JNP.dot. All right? So it's absolutely the same, isn't it? And yeah, do we have any questions about this one? It's super easy, right? Yeah, it should be all good. All right. So here we have another example. So here I'm trying to plot the sinus function, all right? So what I have to do is that I have to import NumPy as NP, I have to import matplotlib as PLT, and then what I try to do is that I take the values between 0 and 10. So this is the linear space between 0 and 10. So basically, I'm creating a lot of points. So for example, I have 0.001, 0.002, etc., until I get from 0 to 10. All right? And then what I have to do, so here I'm using the cos function instead of the sine function, but it's basically the same. Y is going to be the cosine of x, all right? And then I'm going to plot it. So here we should have like a plot of the cosine function. On the other hand, I'm going to just import the JAX NumPy instead of NumPy. So it should be one import in here and not two imports. And then I'm going to import matplotlib exactly in the same way. And then I'm going to replace the NP with JNP. I'm going to replace the older version of NumPy with the JAX version of NumPy. Okay? And it's going to run. Here we are building something a little bit more complicated. It's called the rotation matrix. So basically the rotation matrix is a predefined matrix. It is, if you multiply it with your vector, it's going to rotate it, all right? So for example, I have a vector that points in here, and then I multiply it by this rotation matrix. It's going to go here. So I'm going to rotate it, okay? So here we import NumPy. This O stands for theta, so it's basically the degree of the rotation, okay? I just define it in here, and then I build my rotation function. So it's a square function. It's it's square matrix. So it's a 2 by 2 matrix. We have the cosines of theta in here, and we have minus NP sine theta and sine theta in here, okay? And then what we have to do is we have to define our vector, which is 0, 1. So this is the initial vector, and then I will get the rotated vector by just multiplying the rotation matrix by x, okay? Here we have the JAX code. So basically we replace all the NPs with a JNP, okay? So we just import it and then we replace it, and it's going to work. It's so cool, all right? So maybe it's time to go to our Colab. So yeah, I was trying to mess a little bit with Colab earlier. So yeah, just go to your Colabs and let's start working together. So we are going to build a NumPy script, and then we are going to transform it into a JAX script, all right? So we are going to do this rotation matrix multiplication. So please let me know if you're on your Colab and you're ready to code with me, all right? Can you use this in Colab without the top computer or GPU? It will work on a regular laptop. Can you use without like top computer or GPU? So yeah, the JAX code can run on a regular CPU, all right? It can work on your regular laptop. But here in Colab, I'm going to activate the GPU, and I'm going to run the code over the GPUs, all right? So this is the beauty of JAX, because we are able to run the same code that runs on CPU into a GPU or a TPU, all right? So I'm trying to exploit that feature. So yeah, Mary is ready. Who is also ready in here? All right, Selena is ready. Good, good. Kieran, Andre. All right. One more participant and we're ready to go. So yeah, who is ready? All right, Sean, Arnold, good. So yeah, I'm just going to delete this. I'm going to zoom in a little bit to make sure that you can follow up with me. So here I'm running on a GPU. So here where you choose your accelerator, all right? You can work with none, which means you're working with a simple CPU. You can choose a GPU or TPU. So in my case, I'm using a GPU, all right? So here what you have to do is that we start by importing NumPy. So this is how we used to do things. And then what I'm going to do is that I'm going to import jax.numpy as JNP. So it's NP with a J before, because the J stands for JAX, all right? And I'm going to run this code. So first of all, I'm going to build my rotation matrix, okay? So the rotation matrix is going to be a matrix. So it's 2D array. Oops. All right, good. So rotation is going to be a NumPy array, and it's going to contain, so yeah, I need my theta in here. So for example, it's going to be NP pi over 6. Let's make it 6. And then we have the cosines in the diagonal, so it's going to be np cos theta, and we have np sine theta. I don't know if you're pretty familiar with this rotation matrix, but it's a thing in linear algebra, all right? So it's just a matrix that if you multiply it with a vector, it's going to give you the rotated vector, all right? And yeah, here we go. So this is our rotation matrix. I'm going to plot it in here. Cool. So now what I need to do is that I need to create. So which menu option can we change to GPU or CPU? All right, Andre, I'm going to repeat it. So you go to runtime, and then you can click here, change runtime type, and you have this. So here we can choose CPU or GPU, etc. All right. Now we create our vector. So it's going to be an NP array. So it's going to be a two-dimensional vector. So for example, let's take 1, 3. Oops. All right. And then here we are going to get the rotated vector. So we are going to do a dot product between the rotation matrix and x. Okay. So if I run this, I will have my rotated vector. So this is the rotated vector. And here, this is no more than the NumPy code, okay? NumPy code. So what I'm going to do is that I want to transform this into a JAX code, okay? So that it can be optimized. So what I'm going to do is that I'm going to take all the NP and I'm going to replace it with JNP, okay? And I run it. And it's going to give me this. So it's called a device array, and it's going to yield the same results. Okay? And this is how you run a JAX code. So it's super easy, isn't it? I'm going to give you the NumPy code in case you couldn't write it on your own. Just copy paste it, and then transform the NPs into JNP and run it. And it should run. Okay? I'm going to give you a few minutes to do this. So yeah, if I share the notebook with you, we wouldn't be able to work together. Okay. So I'm going to give you the code in here in the chat so that you can copy it and paste it on your own. All right. And of course, by the end, I'm going to share with you the full notebook. Yeah, good. So yeah, please let me know if it works for you. All right, good. We have the first one. Sean, it works fine. Perfect. Arnold, good, amazing. So yeah, Mary, it works for Mary too. So yeah, that's perfect. That's so perfect. So yeah, we don't have much time to try the other scripts, but basically that's it. You take the NumPy script, and then all you have to do is that you replace the NP by JNP, and it should run. Okay. So yeah, let's start now with the very first feature of JAX. So as we said, with JAX, we can create what we call JIT functions. So JIT stands for just in time, okay? So like in the classic way of doing Python, we write the function. So for example, def matrix multiplications, take two matrices and then return the dot product of the matrices, all right? So basically this is a Python function. So you should know that if you execute the code with this function inside, the Python interpreter is going to go to the function and execute it every single time, all right? So it's going to execute it line by line, all right? With JAX, we can do it in a more efficient way. So I type my function, so I have it like def matrix multiplication, etc., and then I gave it the decorator JIT, so that Python is going to understand that you need to compile this function, and then if you want to run it, you only have to execute the machine code, all right? Don't go to Python and execute the lines one by one. You only need to execute the machine code, like the compiled version of the function. And usually the compiled version of a Python function is much faster than the function itself, okay? Because all the instructions are optimized and they are mixed together, so it's just a binary code instead of a Python code. So yeah, JAX is going to give us this ability. So JAX allows you to transform your own functions into JIT compiled versions using XLA. All right. So you should know here that JAX also relies on a lower level framework called XLA. So XLA stands for Accelerated Linear Algebra. Okay. So I think it's also built by Google. So it's kind of library. It's a software that is going to accelerate all linear algebra things. All right. So for example, if we deal with vectors and matrices and tensor, it's going to be accelerated due to this XLA. So you should know that TensorFlow also runs over XLA, okay? So this will increase the computation speed by adding a simple function decorator to your computational functions, JIT. So this is like a pretty basic code to how to use JIT. So from JAX, import JIT, import jax.numpy as JNP, okay? And then we have our function. This is the real U function. I don't know if you're, yeah, so XLA stands for Accelerated Linear Algebra. So I don't know if you're pretty familiar with the real U function. So a real U function is pretty used in deep learning. So it's going to return 0 if x is negative, and it's going to return x if x is positive. So it's going to be something like this, and then it goes up. So I think I can, maybe you can, so real U function. All right, so here it is. So this is a real U function. So if x is negative, it's going to return 0, and if it's positive, it's going to return x itself, okay? So it's really used in deep learning. So here, if I wanted to return like the compiled version of this function, all I have to do is to type this at JIT, okay? And ta-da, you have your JIT function. So this is used to XLA. So that's really perfect. And about XLA, so XLA, or the Accelerated Linear Algebra, is basically the foundation of JAX, all right? This is what basically makes JAX so powerful. I don't know if you have to give me permission to see. Can you see the screen or not? All right, I think it's on your side, Alicia. So try to fix it. All right, good, perfect. So as you can see here, this is the JAX logo and this is the XLA logo, and you can basically understand why JAX is so based on XLA. Like even the logo is basically the same. Okay, so yeah, you should know that XLA is the very foundation of JAX itself. So yeah, so it was developed by Google. It's a domain-specific graph-based just-in-time compiler for linear algebra that can significantly increase computational speed through a variety of whole program optimizations. So you shouldn't really like basically XLA is going to take a script and it's going to optimize it using kernel fusion. Okay? So basically, it will take many instructions and then mix them together so that they will represent a single optimized instruction. Okay? So yeah, this is basically XLA. These are the two logos. So I think, yeah, before going any further, we should try some JIT scripts together. Okay? So we should go back to our collab, and then let's start with some JIT functions. So here I'm going to do JIT. All right. And let's type some stuff. So for example, what I want to do here is create a function. I'm going to call it the power sum. So basically what I want to do is that I want to take a matrix and then add it to its square matrix and then add it to its cube matrix, etc. All right. So I'm trying to build a function that is really computationally expensive. Then I'm going to optimize it. Okay. So here I'm going to take x as an argument, and then I'm going to return x plus np.xx plus np.x x. So this is the matrix itself plus the matrix square. So it's going to be something like this: x plus x to the power of 2 plus x to the power of 3. Okay? And let's just make sure that it runs correctly. So np random power sum. Yeah, so we have problem in here, dot missing value. All right, we're having. Oh yeah, it should be x in here. All right. So if I type the shape of this is going to be 1,000 by 1,000. Perfect. So this is the NumPy version of this code. Now I'm going to write it with JAX, and then I'm going to get the JIT version of it. Okay. So if I want to write it in the JAX format, what I need to do is that I'm going to take a copy of the function. I'm going to call it JAX, and then I'm going to replace the NP by JNP. Okay. And I can make sure that it works by doing this. So I'm running it, and it gives me a result. It gives me the correct result. So if I check the shape, it's going to be 1,000 by 1,000. Okay. So now what we do is that I'm going to get the JIT version of it. So it's going to be like this, JIT. I'm going to call it JAX power sum JIT. And then I would be able to run it. Now, the code isn't going to work because I didn't import JIT, so I need to import it first. So from JAX, import JIT. And now it should run. So I'm going to take this function, and I'm going to give it x. I'm going to run it. Okay, cool. So what I'm going to do now is that I'm going to do a comparison between NumPy and a JIT version of JAX, okay? So to do an execution time comparison, there is something called timeit on Linux, and you can use it on your notebooks, basically. So timeit, and then you put the script that you want to time, all right? So if I use the power sum np, so this is the NumPy version, it's going to take a while to run. So yeah, it's taking 118 milliseconds, all right? Now let's take the JIT version, and I run it. So it took 1.8 milliseconds. So here you can see the difference in speed between NumPy and JAX. So with NumPy, it took 118 milliseconds to only do 10 loops, all right? But on the other hand, using the JIT version of JAX, it only took 1.8 milliseconds to do 100 loop. So basically, this is, I think, 1,000 times faster, since we're having 10 more loops in here, all right? So you can conclude that JAX, in some cases, is 1,000 times faster than a NumPy script, all right? I'm going to send you the code to try it. So this is the code here in the chat. I'm going to send you the two comparison scripts. So I have the JIT version in here. And yeah, and you should be able to run it. So it's so impressive, like the gap, like the difference in execution time between both codes. So yeah, I'm going to give you a minute to try it out. And please let me know if it works for you, all right? Yeah, that's so cool, isn't it? I don't know if you heard about BERT. So BERT is a deep learning model. It's specialized in language, etc. So Google tried to run BERT using JAX. All right. So they kind of built BERT over JAX, etc. And it was running 12 times faster than the usual BERT. Okay. So that's really cool. So with NumPy, it's 139. With JAX, it's 8.33, and with JET, is even faster. So here we can see like the difference between the scripts, and it's so impressive. So basically, whenever you have like a lot of mathematical linear algebra stuff, like a lot of matrix multiplications, vectors, tensors, etc., XLA or JAX is expected to run better than the NumPy code. All right. But in some cases, NumPy can work better, okay? So yeah, maybe we should try another thing in here. So yeah, let's just build a small neural network. So I'm going to call it neural network in here, neural network from scratch. So here we will have the NumPy version, okay? So I'm going to call it network NP. It's going to take X and W. So this is just a one-layer network, okay? And we are going to return, so it's W, so W for the weight and B for the bias. So it's going to be NP dot WX plus B. Okay. Now this is the NumPy version, and we are going to have a JAX version in which we are going to replace the NP by JNP, okay? And here we are going, so this is another way to define a JIT function. So instead of just putting a decorator in here like this, I'm going to do something else. I'm going to do jax.jit, and I'm going to give it the name of the function. All right, so jax.jit, I give it the name of my JAX function, and it's going to return the JIT function in here, okay? So I'm going to define W, which is an NumPy array of 256 by 100. B is going to be a NumPy array of 256. And X is going to be a NumPy array, so X is the input, of size 100. So let's just make sure that our code is running well. So we'll give it this. I feel like something is wrong in here, I think. Oh no, it's not array, it's random.rand, because we are building a random array of shape, of this shape. Okay. All right, if I check the shape, it should be 256. Good. So yeah, it's working. So if I do this and I check the shape, it should be 256. Perfect. So now what I'm going to do is that I'm going to time this. And then I'm going to time the JAX version. And then I'm going to type the JIT version, okay? So I'm going to send you this code in here in order to can you see now? Sorry, I didn't check the chat. Do you have any issues in here? All right, good. So, all right, all good now. Good. So yeah, I just built a really small neural network. So it's just a one-layer neural network. So basically, we take a vector, we multiply it by a matrix, and then we add another bias vector. I just sent you the code in here. I just want you for now to run the code and do a comparison. Okay. So yeah, I'm going to time the JAX version and the network and the JIT version. So now in this case, as you can see, the NumPy was more performant than JAX and JIT. All right. So if you do a comparison between the JIT version of JAX and a simple JAX, we can notice that JIT is much more. It's like twice faster than the JAX version, but for NumPy, it's much faster. The reason is that here we have very few computations because we only take one matrix and we multiply it by a vector. So in the case where we had like very few computations, NumPy can outperform JAX. But on the other hand, if you have like some heavy computations, JAX is expected to do much better. All right? So this is just to show you that JAX is not always faster than NumPy. It's just in the case where we have a lot of heavy computations. So basically, that's it for JIT. What you should keep in mind is that you can do this in two ways. So you either use the decorator JIT over the function, and you're going to have the JIT version, or you build your function and then you use jax.jit in order to retrieve the JIT version of that function. Okay? So these are the two options that you have. Now let's go to do something else. So back to the slides. So we're done with JIT. We are going to see the gradients. Okay? So earlier I told you that using JAX, we can build functions and then we get the derivatives of these functions. So it's really useful. So in order to train machine learning models such as neural networks, or in the case in which you want to use SVMs, or you want to train your linear regression model or logistic regression model, you would need to do backpropagations most of the times. All right? So in backpropagation, we need to do what we call gradient descent. All right. So gradient descent is just an optimization algorithm in order to optimize our functions. And in order to do this, we need to compute the derivatives of functions. Okay. And hopefully using XLA, you would be able to do this in a very easy way. So all you have to do is that you build your function. In this case, it's the sigmoid grad function. So the sigmoid function is 1 over 1 plus the exponential of minus x. So the machine learning or deep learning guys should be familiar with this. Otherwise, it's just fine. It's just a mathematical function, okay? And you only add the grad decorator in order to get the gradient of this function, okay? So yeah, so from JAX import a grad, exactly like JIT, and then we import J and P, and we just run it. So if I go to my code again, I'm going to do something pretty similar. So I'm going to do grad. So yeah, let's just build a mathematical function. So first I need to import. No, from JAX import grad, I'm going to make it ready. And then I'm going to build a function. I'm going to call it f, okay? So f of x is going to return, so I'm going to do something like this, actually. Fx is going to be x to the power of 3 plus 5x to the power of 2 minus x plus 2, okay? So, of course, the derivative of this function is 3x to the power of 2 plus 10x minus 1, okay? Yeah, so the derivative of this is going to be this. So the 3 goes down, and then we do minus 1 in there. So here the 2 goes down, so it's going to be 5 times 2. So it's 10x minus 1 plus 2. So the derivative of a constant is 0. That's why we took off the 2. So yeah, it's going to be x to the power of 3 plus 5 times x to the power of 2 minus x plus 2. Okay? And yeah, let's just take a look and run this function. So f of 3, so yeah, let's just make it simple. So f of 2 is 28. So let's make sure that the result is correct. So it's 2 to the power of 3, which is 8, plus 5 times 2 to the power of 4. So it's plus 5 times 4, so it's 8 plus 20, that's 28. And then we have minus 2 plus 2, so that's 0. So it's going to give us 28. Okay, so f is basically working. Now let's compute the derivatives of f. So I'm going to create a function called fgrad, and it's going to be jax.grad f. Okay, and I'm going to compute the gradient of f in the point 2. And it gives me something like this. It gives me 31. Okay, so if I try and I replace 2 in the derivative function, it's going to give me 31, hopefully. So it's 3 times 4, which is 12, plus 20, all right, minus 1. So this is 32 minus 1, which is 31, which means that my derivative function is working perfectly. Okay, so this example is so basic. I'm going to send it to you right now. So all you have to do is that you can create any mathematical function. You can put some logs inside, some square roots, some exponentials, some fractions, etc. And then you can retrieve the gradient of that function in such an easy way. All right. So with NumPy, you won't be able to do this. If you try to do it with TensorFlow, it's going to be super hard. At least for me, I don't really like TensorFlow. If you do it with PyTorch, it's going to be easier, but still, compared to JAX, it's going to be more complicated because you would need to do some backpropagation, and then you get the gradient from your variable tensors. It's a whole mess. With JAX, you only build the function, you take the gradient of that function, and then you use it as another function. Okay? So yeah, do we have any questions so far in here about the gradients? Is everything okay? All right, Andre, Mary. All right, good. Happy to know that. So, when we talk about gradients, we can have, well, at least when we talk about mathematical functions, we can have 4 types of functions, okay? So we can have one input, one output function, which means that a function takes one input x and outputs one output y. And we can have a function with multiple inputs and one output. So for example, f of x1, x2, x3 equal y. So 3 inputs, 1 output. We can have a one input function and multiple outputs, and we can have multiple input functions and multiple output functions. Okay, so I'm going to show you an example of each one of these. So here what we've seen is a function with one input and one output. Okay, so we input one value and we output one value. Now let's take a look at a function with multiple inputs and one output. So I prepared something here in order to explain it well. Multiple inputs, one output. All right, so here is the function f of x0, x1. So we have 2 inputs, so it's multiple inputs. And it's going to return one value, all right? So it's going to return x0 squared plus x1 squared plus 2 times x0 plus 3x1 plus x0 times x1, all right? So it's a slightly more complicated function. And yeah, if we try to calculate the derivatives, so x0 is going to have its own derivative and x1 is going to have its own derivative, all right? So this first formula is the derivative of x0. It's going to be 2x0 plus 2 plus x1. And this is the derivative with respect to x1. So it's going to be 3 times x1 squared plus 3 plus x0. So it's some simple calculus, all right? So here, to make it quick, I prepared the function. So here is the function in here. All right. So notice something. Notice that I only had x in here, and I didn't make like x0, x1. So x in this case is going to be a vector that contains both x0 and x1. All right. So you need to understand this. When we do JAX, the functions only take one argument. You can't have many arguments. But in that one argument, you can put many elements. So for example, if I want a function with 3 inputs, I just need to pass a 3-dimensional vector to that function, okay? So by doing this, we have x0 squared times x1 to the cubic plus 2x0 plus 3x1 plus x0 times x1, all right? And now I can calculate the derivative. So we will have f grad is equal to JAX.grad f, and then I'm going to have my vector here. So x0 is going to be 1 and x2 is going to be 2. Maybe x0 is going to be 1 and x1 is going to be 2. And then we calculate f grad of x. And it's going to be this. It's going to be 6, 16. So the first is for x0 and the second is for x1. All right? And you can actually verify this. So if we replace 1 and 2 in x0 and x1, we are going to have 2 times 1, which is 2, plus 2, which is 4, plus 2, which is x1. So it's going to give me 6. So it's correct. And if I try to verify the second formula, so it's 3 times x1 squared, so it's 3 times 1, which is 3, plus 3, plus, no, it's 3 times x1 squared, so x1 is 2, all right? So it's going to be 3 times 4, which is 12, plus 3, which is 15, plus x0, which is 1, so it gives me 16. So the gradients are correct, okay? So this is in the case of a function with multiple inputs and one output, okay? We can have a function with with one input and multiple outputs. So it's going to be, so one input, multiple outputs. So yeah, let's take a look at this. So this is my function. F of x is going to return 1. It's going to return x. It's going to return x squared and x cubic. All right, so we have a function with one input and 4 outputs. We have 1, x, x squared, and x cubic. All right, and I want to take the derivatives of this function. Now, in this case, we are no longer going to use JAX.grad, but instead we are going to use JAX.Jacobian. Okay? So the Jacobian is like gradients, but it's in the case where we have multiple outputs, okay? And yeah, basically, it's going to be like this, f grad, and then we can just calculate the gradient of 2, okay? So it's going to give me 4 outputs, which is a gradient for each formula, for each output. So it's going to give me a 0 for the first output, and it's pretty logical because 1 is constant, so the derivative of constant is 0. Here is going to give me 1, because the derivative of x is 1. Here is going to give me 4, because the derivative of x squared is 2x, so 2 times 2 is 4. And here is going to give me 12, because the derivative of x cubic is 3 times x squared, so 3 times 4, which is 12, which is correct. All right? So this is in the case of one input and multiple outputs. And finally, we have multiple inputs and multiple outputs. And yeah, it's going to be exactly in the same way. So yeah, once again, we create our function. We only take one argument that contains the inputs inside. So we have x0, x1, 2 times x0 plus 3 times x1, x0 squared times x1 cubic. All right, so it's a little bit complicated, but it shouldn't raise any problems. And here we create the Jacobian of f, and we pass our 2 inputs, and then we get something like this. So for each input, we have a derivative, and for each output, we have a derivative. So we will end up with a matrix of 4 by 2, 4 for the outputs and 2 for the inputs. Okay, and ta-da, you have your Jacobians, you have your gradients, etc. So this is one really, really powerful feature of JAX, and it's absolutely magnificent. And yeah, one last thing, which is really impressive. I don't know if you thought about it or not, but what if we want to take the second order derivative, which means that what if we try to take the derivative of a derivative of a function? Okay, and second order derivative. And we can actually do this. So I prepared a whole script for this. So here, let's take a look. First, I will have a function which is x to the power of 3, all right? So the first derivative is 3 times x to the power of 2. The second derivative is 6x because we have 3 times 2. The third derivative of x is 6, and the fourth derivative is 0, all right? So we take f, it's going to return x to the power of 3, and then we take the nth order derivatives. So this is the first derivative, and then we are going to take the gradient of this gradient function, which is the second order derivative, and then we take the third order derivative by taking the gradient of the second order derivative, etc. So here we will end up with 4 new functions, and we can check this out. So we have the first derivative is 12, because it's 3 times 2 to the power of 2, so it's 3 times 4, which is 12. Here we have 12, we have 6 in here, and we have 0 in here. So we can confirm the results. All right? So once again, another cool feature of JAX is that you can take derivatives of derivatives of derivatives, and you can just create a chain of derivatives, etc. So this is so good. I'm going to share this with you. So do we have any questions so far about gradients? I know there's a lot of calculus inside, but don't worry, it's super easy. JAX is going to take care of everything, all right? So if you don't have any questions, we should pass on to the last point, like the last feature of JAX. It's absolutely not the last, but it's the last basic feature, okay? All right, no question. All right, what about the others? Come on, guys, any questions? Should we move on? All right, Sean, all good. Cool. All right, so maybe, yeah, we need to pass on. I'm going to send you the notebook when we finish. So, yeah, this is for the gradients. So again, you have 2 options to do gradients, actually. You can work with the decorator, or you can use the JAX.grad, okay? It's up to you. Now, finally, we are going to talk about the vectorization, okay? So vectorization is actually super easy. So imagine that you have a vector, and you want to like a vector of numbers, okay? And you want to apply a function over each element of this vector, okay? So it's actually called mapping. So it's kind of taking a function and you map it over all the elements of the vector. So if we do this with like the vanilla Python, with the classic Python, it's basically taking the vector, creating a loop that is going to loop over all the elements. We apply the function on the elements, and then we store it, okay? So we're creating a loop, etc. But with JAX, we can do something called vectorization. So basically, we take the whole vector, and then we parallelize this process. So instead of creating a loop, it is going to apply the function on the elements one by one. We are going to apply the function as all the elements at once. So we are parallelizing the work of all the elements. So it's like in here. So we have our elements in here. They're all going to pass through the function, and we are going to retrieve the results. So this is going to increase the performance, like the execution time of the script. So once again, it's done with the same simple syntax. So we import Vmap. It's called the vectorization map. So Vmap, and we can use it like this. So yeah, we create our function. So this is the function that we are going to apply. I call it f of Vmap. And for example, it's going to return minus x to the power of something, okay? And then create a vector that contains a lot of elements. So for example, here it's contained the range from 0 to 100. So we have 0, 1, 2, 3, 4 until 99. And then we are going to apply this function on all of the elements at once, okay? So yeah, it's just Vmap of x, and it's going to work. So yeah, I prepared some really small scripts to do this. So let's just execute some stuff together. So yeah, I think this is the coolest part of the workshop. because, oops, so I have Vmap in here. So let's say that I had a function, okay? So this function, I'm going to call it f again. So it's basically something like this. So it's minus 1 over 14 times x to the power of 3 plus 1 over 4 times x to the power of 2 plus x, okay? And what I want to do here is that I want to plot this function, okay? I want to plot it. So what I need to do is that I need to create linear space. So I'm going to use JNP in this case. So we have the linear space like this. So I'm going to create a linear space from -5 to 5 with 10,000 elements inside. All right. So x is going to be like this. It's going to be a vector. So we have -5, -4.9999 until 5. So if you check the shape, it's going to be 10,000. All right. Now, if I do f of x, we are going to apply f on all of the elements, all right? So x is a vector that contains a lot of numbers. And by doing this, JAX NumPy is going to automatically apply the function on all of the elements of x. And basically, this also works on NumPy. But it's not what I'm trying to do here, all right? So I think we should import matplot lib.pyplot as PLT. What we are going to do is that we are going to PLT plot f of x. And here is it. This is our function, f of x. So we took many inputs. We calculated their transformation, their fx, all right? And then we plotted it. We plotted the result. So this is the function. Now, what I'm trying to do here is actually not just plotting f, but I also want to plot the gradient of f, okay? So what I do is that I create another function. I'm going to call it f grad 1 or f derivative 1, and it's going to be the gradient of f. Okay, it's going to be something like this. I'm going to comment this. Now, if I do this, it's going to raise an error, all right? So fd1 is the derivative of f. And what I'm trying to do here is that I want to map it over all the elements of my vector. And apparently, it raises a problem. So the type error is gradient only defined for scalar output functions. Output had 10,000, all right? So one thing about JAX is that if you want to take the gradient of an input, all right, it should be one-dimensional, okay? But in this case, it's a vector of input, so it shouldn't work. What we should do instead is just take the Vmap of this. So jax.vmap. So we are going to vectorize this function, and then we should apply it over our inputs. So yeah, it's actually not doing, it's actually done like this. So jax.vmap. All right, so now VD1 is going to use the vectorization map in order to apply over all my inputs. So now it's working, all right? I'm applying the gradient function over all of my inputs. So now if I want to plot fx1, I would also be able to plot fd1, and it's going to give me something like this. So the blue function is the original function f, and the orange function is the gradient function. So it's the derivative of f, all right? And it's super cool because we can do this with just a few lines, okay? We take the function, we take its derivative, we take the vectorization map of that function, and then we just apply it on our inputs, all right? So we have like a huge input. So we are going to apply these two functions over these inputs. What I can also do is that I can take the second order derivative, okay? So it's going to be Jaxgrad of f. All right, so like we have some nested gradients. So we take the gradient of f, and then we take its own gradient, and then of course we need to take the vectorized version of the function. We are going to call it fd2, and we are going to also plot it, okay? So if I do this, it should also work. So here, take a look at this. The blue one is the original function, the orange one is the first order gradient, and the green one is the second order gradient. All right? Which is absolutely magnificent. And we can take this even further and take the third order gradient, and we should take we should have a constant line by the end. Okay, so I do this, I replace this, and then I'm going to plot third one, and here we are. So the red one is actually the third order derivative. Okay, and it's pretty constant in here. So yeah, basically that's it. So we took function, we took multiple derivatives, we took the vectorization map using JAX, and then we applied this on our inputs, and we got this little mess. Okay. So yeah, back to the slides. So I think that was it. So we've seen how to create JIT functions of Python functions, like the JIT versions of Python functions in JAX. We learned how to take the gradients of multiple mathematical functions. So it's either one input, one output, or one input, multiple outputs. Or we can have so yeah, in the case of one input, multiple outputs, we should use the Jacobian instead of the gradients. And we can have the inverse. So we can take multiple inputs with one output, and we can take multiple inputs with multiple outputs. And one other cool thing about JAX is that you can take the gradients of a gradient function. And you can take the gradient of the gradient of a gradient function, and you can create some nested gradients, all right? So you take a function, you can end up with the 10th order derivative. And it's going to be super, super fun and super, super quick, all right? And by the end, we took a look at the vectorization map. So basically, if you want to parallelize the work of mapping the function over a vector, you can use this vectorization map. So instead of having a loop, this is going to loop over all of the vector. We are going to parallelize the work, so the function is going to be mapped over all of the elements at once. Okay, and yeah, basically that's it. So a bit off-topic question: do you know if JAX or even TensorFlow has support for the new neural processing unit (NPU) from Apple? Or no, I do not know. I do not know that. Could you share your Colab notebook? Yeah, absolutely. I'm going to share it with you. So yeah, I'm actually going to share with you the version that I have on my computer. Like, it's a full version that contains comparisons, time execution comparisons, gradients, JIT versions, and vectorization. So I'm just going to. All right, amazing workshop. Thank you. I'm ready for your questions. All right, guys. So you can ask any question that you have. So yeah, just give me a minute to. My computer is a mess. I need to find the notebook. All right. So yeah, workshops, JAX, and yeah, it should be this. So yeah, it's uploading. Do you want me to talk about the schedule of the bootcamp, of the data science bootcamp? All right, good. So yeah, in data science bootcamp, we have many units. All right, so we start off with some Python. All right, so it's just, we call it the preparation unit. All right, so we do a lot of heavy Python. We learn about SQL. We talk about GitHub, etc. So how you manage your projects, etc. We talk about some linear algebra, some probabilities. So all the stuff that you need in order to pursue your career in machine learning and deep learning. And then we have the data analysis unit. So it's the unit in which you get familiar with data. So we bring data sets, we manipulate them. We use SQL also, we use Pandas, NumPy. So basically we take a look at everything. Yeah, exactly. I'm talking about the schedule of the data science bootcamp. I think you can find all these details on the website, but still, I'm going to talk about it. And then we have the machine learning unit. So this is when things get really, really interesting. So we take a look at a lot of machine learning algorithms like linear regression, logistic regression, naive Bayes, tree Bayes methods, boosting Bayes methods, SVMs. We take a look at neural networks also. And it's not just coding, but we try to understand the fundamentals of things, all right? So we teach you about the math behind it. We code it from scratch together. And yeah, by the end of each week, you will have an exercise that you need to submit. And by the end of each unit, you will have a project that you need to submit also, all right? And then we have deep learning. So in deep learning, we get more specialized in neural networks. So we dive deep in them. We try to understand how they really, really work inside. We treat their problems. We build them from scratch. We do back propagation together, forward propagation together. And yeah, we will have a lot of projects, okay? And then we will have two more units. One is for computer vision. So in this unit, we are going to dive deep into computer vision stuff. So we learn about CNNs. So we learn about CNNs, like image classification, object detection, segmentation, image generation, like GANs. We talk about diffusion models, etc. And then we will have the NLP unit, in which we talk about natural language processing. So we talk about RNNs, LSTMs, etc. And then we talk about transformers, which is pretty famous. We talk about BERT, about GPT-3. We talk about, so I think you guys are pretty familiar with GPT-3, all right? So yeah, it's going to be pretty intense. And also by the end, we will have a final unit to talk about deployment. So we will teach you how to deploy your own models using GCP, etc. So it's going to be super cool. So I knew nothing of JAX, and now I want to learn more. All right, Mary. I'm so happy to know that. And could you talk about Code Labs Bootcamp when remote? So when we do it remotely, basically, I'm going to talk about the part-time version, okay? So basically, we will have 3 sessions per week. So 3 sessions of 3 hours or 2 hours and a half. So it depends on the lessons. And yeah, we can start off with a course with your teacher. So it's going to be a meetup with your teachers. You can interact with them like as free as you want. They are so friendly, basically. So you have me. Yeah, I'm pretty friendly. So you have me, you have Kenza, you have Riyadh, etc. So they are really friendly. And yeah, we will do some homeworks together. They will give you assignments. You can work on them during the lesson, and then you can correct it. You are going to learn how to present your work. You are going to work on your soft skills and hard skills. You can organize some one-to-one meetings with your teachers. So for example, you're a little bit off topic, so you didn't really understand something. You can just request a one-to-one meeting, and then you have it, all right? You can have some mock interviews, etc. So the program is so intense, and it's going to be so cool because, by the end, you are going to end up with tens of projects in your portfolio. You are going to end up with a lot of theoretical background, like mathematical and probability background. You will learn how to code, how to build huge projects, etc. So it's so perfect. So thank you, Bernard, for sending this to Andre. Can I study in Code Labs Academy, but in self-paced way? So I don't know what exactly you mean by self-paced, but the part-time option, you are going to have only 3 sessions per week, and you will have the recordings, you will have the lessons on our platform, you can submit the homeworks as you want, etc. So it's going to be pretty lightweight compared to the full-time bootcamp. When you be sharing the notebooks here or by email? So I think I'm going to use this. Because it took a little bit of time. So I'm going to share it here. We will be sharing the notebook. Are the lessons always live? Which time slots are available? So the lessons are going to be live, but we can record them, all right? But basically, your presence is a must, all right? Because you need to interact with the teachers, etc. So we can talk about the schedule once you apply, and then we can find you like the best time slots for you, all right? Okay. So I think, guys, I'm going to send the notebook by email. because yeah, I couldn't send it here, and I think the website is down. So yeah, I'm going to send you the notebook by email. All right. I have all of your emails in here, so I'm going to send it. So, any more questions? Thank you, Andre. It was a pleasure. All right. So yeah, by the way, we are going to have two more JAX workshops. So I didn't fix the time yet, but we are going to see more advanced JAX things. So yeah, if you want to continue with me, just stay tuned. We are going to post about them in our website. So the next one is called building machine learning algorithms using JAX. So we are going to build linear regression and logistic regression using JAX. And the third one is actually called building a neural network with JAX. All right. So we are going to build a neural network from scratch using only JAX functions. Okay. Yeah, of course. All of our workshops are going to be available on Meetup, and I think they are going to be held here in Demio. And yeah, we are going to post about them in our social media accounts. So just go to Instagram or LinkedIn or Facebook, type Code Labs Academy, and yeah, we are going to announce on all of our workshops in there. So yeah, just stay tuned. All right, Bernard. All right, Andre. All right, so do you have any more questions? All right, so for the last time, we also have two more workshops today. So we have, I think we have a web development workshop and we have a Python programming workshop by the end. So yeah, if you want to join, you can just go to the website and register for the workshop. Okay, and that's it. How do JAX and PyTorch compare in terms of ease? Learn in your opinion. So yeah, uh, this is actually a really good question. So PyTorch is actually a deep learning framework. All right. So with PyTorch, we'll be able to build neural networks, CNNs, RNNs, transformers, etc. But JAX is just for the low-level operations. Okay. So for example, with JAX, we can build a framework like PyTorch, but you can't find like the same functionalities in PyTorch and in JAX. So for example, you can find pre-built architectures in JAX. All right, you can't find neural networks in JAX unless you build them yourself. So JAX is for the low-level operations, but PyTorch is for it's like a higher-level framework. All right. All right, good. So Selena said that I signed up for the web development workshop, but Python workshop seems to be sold out. I think it's not. I think you can still register for the Python workshop. I don't know. Okay, just try again. All right, Selena. All right, good. So yeah, one question. Do you have any experience with PyTorch or TensorFlow? Like especially for Sean, I'm talking to Sean here because you're asking a lot about PyTorch, and I would love to know if you have any experience with it. All right, so yeah, PyTorch University. All right, good. So PyTorch, I really love it. I only work with it. So it actually depends. So if you're research driven, if you want to dive into deep learning research and stuff, it's better if you work with PyTorch, okay? Because with PyTorch you can debug your model. You can like look at deep things inside, all right? But in TensorFlow, it's actually not that easy. So TensorFlow, when you build the model in TensorFlow, it's kind of a black box. So you can't really access what's happening inside, okay? So in the case of a problem or in the case of a bug, it would be really, really, really hard. At least for me, it was really hard for me to debug the things. So that's why I prefer working with PyTorch. And you know, PyTorch is also more Pythonic. So the syntax in PyTorch is so similar to the Python syntax. But TensorFlow is a little bit more complicated. All right? So yeah, thank you guys for joining me today. So I'm going. This is my my email. Collabs Academy. All right, you can just contact me in here. And yeah, so yeah, we should end this session. I would love to answer all of your questions, but there is a session that is coming up. It's the web development bootcamp. So yeah, we should free the room for them. All right. So thank you guys for joining. It was really a pleasure, and let's meet in the next workshops. All right. Take care of yourself. Bye bye.